Everyone, welcome back. Today we will be talking about regression analysis. Now, what is regression? It is basically this talks about using one variable to predict the outcome of another variable. In other words, if there are two variables which have a correlation between them, then if the change in value of one variable, what would it lead to the change in the second variable? Simplest terms, if you're taking the two sets of variables as x and y, so the change if there is a change in x, correspondingly how will y change? Now please keep in mind that this is applicable and this takes into presumption that we are going to do this only when there is a relationship between the two variables. Okay, so regression basically tells us how to draw the straight line which calculates the best fit line for the set of data. For this, I would also refer to my previous video on correlation analysis, and we'll be taking the example from there, which is in the previous example on correlation studies, we had just used the scatter plot. Today we take it further for regression analysis. So the same set of data, for example, if we are taking it the age versus weight, so if we don't draw the line, so the dots represent a scatter plot and the best fit line between the dots. Okay. That is what is going to represent, or that is what is going to tell you about the regression. That is a regression line. Okay. The same thing for another example, weight versus systolic blood pressures. Okay. Now, what exactly do we do in regression analysis? As we said, we try to provide for a best fit line for two sets of variables. The equation for the straight line is given by y is equal to a plus bx. Over here, y and x are the variables. A and b is the slope, a is the intercept. We'll talk about that. How do we calculate b? Is given by the equation summation of xy minus summation x into summation y divided by n, where n is the total number of observations. This whole divided by summation of x square minus summation of x whole square divided by n. And then how do you predict? For the prediction part, we require two more variables, two more values. One is y bar, which is the mean of the y variables or observations in y, and x bar, which is the average of the x observations. So we take the same example that is the in the previous slide, that is weight versus systolic blood pressure. So we have their calculations, the different observations of x, the different observations of y. We get their sum, so that this 799 becomes summation of x. This gives you the value of summation of x. The 1433 gives you the value of summation y. Then some xy, and then their summation, x square, that summation, and summation of x whole square. So this is the summation of x, that is 799, and that whole square. Besides that, we'll be needing the mean values as well. So basically this is 799 and the total of 10 observations. So the mean for x will become 79.9 and the mean for y will become 143.3. So we just put it in the equation for the calculation of slope b, and here we find out the value of b to be 1.89. So basically we are talking about straight line. We calculated the slope and we got the intercept. In the actual regression analysis, what we do is we basically get any 2 points, or we take any two values of x for which we predict the value of y. Then correspondingly after that we extend that line in both the directions. So the extension of line is going to give you the intercept value, which is a. Now how do you this is one aspect of the calculation of the regression line. How do you predict the value? That means if you are given a value of x, then how do you calculate that what is the predicted value for y corresponding to that? So in that, as we said, we discussed before, we will be requiring the mean for that, and we'll be applying this in the equation where the required value of y is equal to the average value of y plus b multiplied by the difference between the x and the average of x. So if we want to calculate for x is equal to 70, that will be 70 minus 79.9, that is minus of 9.9, that multiplied by slope, that is b, which we calculated of 1.89. So that overall it becomes 143 minus 18.7, that gives you 124.6. It's a very simple concept and a very simple formula which can be applied and used for all sets of data. Advice that students are advised to use the another set of data, that is between the age and the weight, to compute the regression line and predict the value for any given value of x that they want to choose. Thank you.